Hello guys, so in this video we want to start looking at some examples of finding the limits of functions. So we'll start with this set and then look at another set later on. So one says we want to find the limits as x approaches 3 of 2x minus 1 squared. Okay, so we can apply the laws of limits here. First, notice that 3 here, this is a polynomial. So this is continuous for all values of x. So x, obviously, 3 is in the domain of this function. Okay, so we can literally plug in x equals 3. Or if you apply the limit laws, you can write this as the limit as x approaches 3 of 2x minus 1. You can raise all of this square using the power rule, right? So this will be equal to, this is a polynomial again, so you can put 3 there. So that gives you 2 times 3, that is 6 minus 1, all of that squared. So that will be 5 squared, which is equal to 25. So the limit is 25, it's straightforward. Okay? Then number 2, you want to find the limit as x approaches 1 of x minus 1 all over x squared minus 1. Now here you have to be a bit careful, right? Because notice that when x is equal to 1, the denominator is 0. So x is equal to 1 is not in the domain of this function here. And so what you do is that you try to simplify this function here and see whether some terms will cancel out before you find the limit. Okay? Okay, so this is a difference of 2 squares, so that's easy to do that. So we do the limit as x approaches 1, x minus 1 is still the same. This can be written as x minus 1 times x plus 1. You see? It's a difference of 2 squares. So x minus 1 can cancel out this x minus 1. This guy, 1 and 1, right? And so this can be written as the limit as x approaches 1 of 1 all over x plus 1. So now you see that 1 here is in the domain of this resultant function, right? And so we can plug in x equals 1 into this function. So this will just be equal to 1 over 1 plus 1, 1 over 2. So the limit as x approaches 1 of this function is 1 over 2. Okay? Good. Let's do number 3. Get rid of this. Okay, let's come here. Number 3. You want to find the limit as x approaches -1 of the square root of x cubed plus 2x plus 7. Okay, the square root of this is the same as this to the power 1/2, so you can apply the power rule. So this, I can rewrite this as the square root of, I'll take the limit inside, x approaches -1 of x squared plus 2x plus 7. Square root of that. Okay, now this is a polynomial as well, so I can just plug this inside. So this is equal to, well, as long as this is not negative, right? Otherwise, this will give you complex numbers. So you must ensure that, this is in the domain, x equals to -1, right? It's in the domain of this. Okay, so this is the square root of, if I put -1 squared is 1, -1 times 2 is -2, plus 7. That gives me this, and this is -1 plus 7, that is 6. So the limit is equal to the square root of 6. Okay, so that is this. And then we do this one. This last one says we want to find the limit as x approaches 4. So notice this. It says limit as x approaches 4 from the left hand side of square root of 16 minus x squared. Okay, now this approaching 4 from the left hand side is there for a reason. It's very important, right? Because if x is less than 4, right, it's approaching 4 but it's less than 4, that's approaching it from the left, then this will be positive, and so you don't have a negative under the square root. All right, if it's positive here, then we are going to go beyond 4 point something, let's say 5, then this will be negative, and so you can't find the limit of that, or the limit does not exist. So that is why you are taking 4, you are approaching 4 from the left hand side. Okay, so since it's 4 from the left hand side, you can do the same thing, because this is in the domain of that. So this will be the square root of, you can then find the limit as x approaches 4 from the left hand side of 16 minus x squared. Alright, so you have the square root of, you can put 4 in there, right? 16 minus 4 squared is 16. 16 minus 16, that is 0. Square root of 0 is equal to 0. So the limit as x approaches 4 from the left hand side is equal to 0. Okay? If you notice that this is in the limit of this, you could have just put it in here straight away and find the limit equal to that. Okay, so in the next video, I'll do a couple of more examples which are a bit more challenging than these ones. Alright? Okay.